In this lesson, we will be using the spreading effect to create a VDB grow of the sphere. So we already done the two geometry effects nodes, and I think right now we can create the render nodes. We just need to put this aside and create a geometry node that we call render, RNDR, we say sphere. Sorry. And let's dive inside. I need an object merge again to use the spreading points. So we go to the spread effects and we have, let's use maybe this one, out spread age. So these are the points that also contain the age, or maybe, yeah, I think we don't need the age, we just need the spread. Yeah, and that's it's because we need the VDB to be solid and not disappear after the particles die. So again, we have this spreading here. We need to use delete sop again and set it to points. Delete by expression at cd dot x is more than 0.5. And this is really simple to do actually. We just need to set a p-scale. So I say point wrangle set p-scale. I create a parameter called p-scale. This is a default Houdini parameter. It's actually the point scale, and create a channel reference again. So we say p-scale. And what I like to do, this is also, we can apply this also on flip fluid particles where we have a lot of density. I just select a few points and hit a blast inside of the scene. I just put down a copy to points and a normal sphere. Just put this here and this here. Back and distance. So right now p-scale is 0 and I want to put it 0.1. So what happens now is that I can have an approximation of the p-scale before transforming it into VDB, because sometimes if you have the p-scale too low, then the Houdini may crash or the VDBs won't be created. So I just set up a nice p-scale here, maybe 0.1, I think it's, or maybe a bit bigger. We don't need to have holes around here like we have this one, so maybe 0.015, something like this. So this is just for the reference. And now I say VDB from particles. So of course what happens is that it doesn't do anything because of two reasons. The voxel size is too big, and also the minimum, actually the point radius scale needs to be lower. So let's go down, maybe like this. Let's see what it says. Ignore, yeah. So actually it was the other slider. This says that the minimum radius of the points, usually it's too big. So I just put it to 0 because I already know my p-scale, so it's not variable. And you can see right now the VDB particles look exactly like the copy to point scale. What this function does, it creates a sphere over each particle and transforms into a VDB. Maybe right now the resolution is too low and it will take a lot of time to compute. Maybe we put it like 0.002, and I think it's okay this time. Also, I think the p-scale may be too low, so let's say 0.016 maybe. 18. As you can see, there's a lot of tweaking. Okay, so there are several ways to approach this. What I like to do is I like to create a VDB combine and use this just as a mask. It's more computational heavy, but it creates a really nice result. So right now I need to also import the actual sphere. So we say out sphere, and now this is the original sphere that we have. Maybe also make it subdivided, more dense. Yeah, let's use 2. So it's really nice and round. And now I say VDB from polygons. We can use the same resolution. It's a bit heavy to compute, but it results in a really nice sphere. So on the left we have the original sphere that's transformed into a VDB, and then on the right we have the growth effect that's also a VDB. And what we can do, we can combine those and use this as a mask. But let's see, we can also use a VDB smooth, but let's see if we need to use it before the combine or after. So we merge those together, and let's see here, I say SDF intersection maybe. Yeah, so what happens right now is that on the outer shell you can see the nice sphere, and this is acting like a mask, so you don't see the top part. Maybe we can also try another one, SDF difference maybe. Yeah, this is the opposite. So I think intersection is good right now, because we also needed to have some thickness, and on the inside it's nice to have a bit of variation. Now we can do a VDB smooth, maybe set this to 2, and now you can see the outer shell, it's really nice, and in the inside we have some irregulations. They are really nice actually. And then we just need to convert the VDB to polygons. So we say VDB, convert VDB, and convert it to polygons. Of course, the mesh resulting will be really dense, and we need to tone this down a bit. So to do that, we can use the adaptivity, and we can just go 0.05 maybe. Yeah, I hope the mesh looks nice. Okay, now let's do a bit of cleaning. Okay, now we can take the file cache from here, because I'm lazy to write everything again. We just put in here and say sphere VDB, and just compute this. Actually, I'm stopping this because I forgot something. I just need everything until 140, if I remember correctly. So I don't want to save on disk and compute the VDB if not necessary. So here we say 140, and then what we can do, because we are in Houdini, we can just take the same nodes from here, just copy them, go here and paste, and now we will have the same result. So it's reading from the file until 140, and then it switches to the static mesh. So let's compute this again. Caching is complete. It took around 10 minutes. So if you have a look, you see the sphere is growing nicely, and it's also visible after frame 140. Next, what we need to do is to add the age. Next, what we need to do is to add some variation over the shader. For that, we need to import the growth particles with the age and transfer them into a CD over the sphere. So let's make something clear here, that we import the sphere and we just copy this one. Not this one, sorry, in spread. So we copy this one and say in spread age, and here we should find this one. We can just write it manually and we find it. Now we see here is the actual spread, and this is the VDB from the sphere. So let's see what happens. You see they're pretty close together, which is nice. So the points are almost exactly where the VDB is, but also you can see here there's the particles that are dying. So we can create a nice color ramp from those. If we remember, we have the same thing into the spread effect. So let's just find it. I think it's here, set age ramp. So we can just copy this one for now to here. So now we have the same ramp. Of course, we don't want that, so we just need to erase this and maybe have something similar to this, where it's white at the beginning and then fades very slowly to black. Let's see. Yeah, I think something like this. Now we should add a time shift. This will help us later, because we may want to time shift the growth of the sphere and make it grow after the primitives appear. We'll see this later, and just as a precaution, I will just make a reference copy and put it here. So this, if I change this one, the other one automatically changes, and I just need to do an attribute transfer again. So I transfer the CD from here to the sphere. I just want to transfer CD and maybe make sure it's set right. So I think right now it looks really nice. Another thing that I can do is say add attribute blur, and I want to blur the CD, make it really nice. So you can see now it looks really awesome. Okay, and of course I will want to have a texture from disk on this sphere. So for that I would need a new VMap, so the texture won't move when the VDB grows. Let's create a UV project. I think this would work, and also UV quick shade. This helps us to view the UV map. And let's go here. So for the UV project, I just disable this for now to see this without the color. So here I would say color, and yeah, I think it already worked. Yeah, so I think this is what we need, just a really simple one. So right now when the UV stays in place when the sphere grows, and we can attach a texture to it. Now we can enable this back again. I think we just need some normals, so we make sure the surface it's represented correctly. As you can see here, we have some strange things happening. I will put this into points and by face area, and this is usually used in flip fluid simulations, so it's really nice. And then I would say I would put a null and say out sphere VDB, and of course again do some house cleaning. In the next lesson we will start creating some shaders.